Let's explore C++ inheritance, a key concept for building hierarchical relationships between classes. Inheritance is a feature of object-oriented programming. Inheritance is a fundamental object-oriented programming concept that allows a class to inherit properties and methods from another class. The base class is the parent class, while the derived class is the child class. Inheritance promotes code reuse and establishes a relationship between classes. Let's see the basic inheritance syntax. We start with the base class, using the keyword class followed by the class name, in this case base. Inside the class, we define the base class members. Now, to create a derived class, we use the keyword class, followed by the derived class name, in this case derived, then a colon, followed by the keyword public, and finally the base class name base. Inside the derived class, we can define the derived class members which have access to the base class members. There are three ways to inherit from a base class. We have public inheritance, where we use the keyword public before the base class name. We have protected inheritance, where we use the keyword protected before the base class name, and we have private inheritance, where we use the keyword private before the base class name. With public inheritance, public members of the base class remain public in the derived class, and protected members remain protected. This establishes a relationship. With protected inheritance, public members of the base class become protected in the derived class, and protected members remain protected. This is often used for implementation inheritance. With private inheritance, public and protected members of the base class become private in the derived class. This establishes a relationship and is used for composition through inheritance. Here's an example of a shape hierarchy. The shape class has protected members x and y, which represent the position coordinates. It also has a public constructor that initializes these coordinates and a virtual function called draw, which has a base implementation. The key points are that the base class shape defines common properties for all shapes, protected members are accessible to derived classes, the constructor initializes position coordinates, and virtual functions can be overridden by derived classes. This establishes a foundation for polymorphic behavior. Here's an implementation of the derived class circle, which inherits publicly from shape. It has a private member radius, and a public constructor that calls the base class constructor shape with the x and y position, and initializes its own radius r. It overrides the draw function and adds a new function getArea to calculate the area of the circle. Important concepts to note include that public inheritance means circle is a shape. The constructor calls the base class constructor first. The override keyword ensures we're overriding a virtual function. The derived class can access protected members, x and y, from the base class, and the derived class can add new functionality, such as getArea. In the main function, we create a derived class object, circle, with the specified x, y, and radius. We access the derived class method getArea to calculate the area of the circle. We also demonstrate polymorphism by using a base class pointer shape ptr to point to the derived object, circle. When we call shape ptr draw, it calls the circle implementation of the draw function. Derived objects contain all base class members and can be used wherever base class objects are expected. Polymorphism allows calling derived class methods through base class pointers. Virtual functions ensure the correct implementation is called. This is the foundation of object-oriented design in C++. There are three main types of inheritance. Single inheritance is when a derived class inherits from only one base class. This is the most common and straightforward form. Multiple inheritance is when a derived class inherits from two or more base classes. It's powerful but can lead to ambiguity issues. Hierarchical inheritance is when multiple derived classes inherit from a single base class, creating a class hierarchy with specialized types. Here's an example of multiple inheritance with printable, and drawable base classes. The printable class has a virtual function print, and the drawable class has a virtual function draw. The document class inherits from both printable and drawable and overrides their print and draw functions with document-specific implementations. A class can inherit from multiple base classes, combining functionality from different sources, which is useful for implementing multiple interfaces. However, this can lead to the diamond problem if not careful. Use virtual inheritance to solve ambiguity issues, and careful design is required to avoid complexity. Here's how virtual functions enable runtime polymorphism. The animal class has a virtual function makeSound and a virtual destructor. The dog class inherits from animal and overrides the makeSound function with a dog-specific sound. The animal sound function takes an animal pointer as input and calls the makeSound function on it. Virtual functions enable runtime polymorphism. The override keyword ensures correct overriding. Base class pointers can point to derived objects, and the correct function version is determined at runtime. Always include a virtual destructor in base classes to ensure proper cleanup, which enables extensible and flexible code design. Let's discuss some best practices and summarize the key concepts. Always include virtual destructors in base classes to ensure proper cleanup of derived objects when deleted through base class pointers. Consider composition over inheritance when the relationship is has a rather than is a. This creates more flexible and maintainable code. Always use the override keyword when overriding virtual functions to catch errors at compile time and improve code readability. Key takeaways include that inheritance creates is a relationships between classes, public, protected, and private inheritance affect member accessibility. Virtual functions enable runtime polymorphism. C++ supports multiple inheritance but requires careful design, and inheritance is a powerful tool for code reuse and extensibility. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.